Okay, so let us start with the solution of 50th question of Zettili, second chapter and second edition. So this is one of the interesting question I find, because in usual questions we are given the wave functions and we are asked to calculate certain observables, alright. But in this particular one we are given a Hamiltonian operator, and we are asked in the first question itself we are asked to calculate the wave function which gives certain energy eigenvalue, and to see if that is a normalizable function, and if so then we have to normalize it. And in the second question we are asked to find the probability of finding particle in certain region. So this particular thing is, this region is defined between x to 15. And in the third question, so the whatever the wave function we will be deriving in the first part, we have to see if that same wave function is an eigenfunction for another operator, and if so we have to state whatever are the results for the same. And in the last part we have to calculate the commutator of H and A. So let us start with the solution with the very first part. So we are given that there is some Hamiltonian applying on some generalized wave function. We don't know what is the format of this at the moment, and that should give us 9 epsilon and psi. So let us put the value of h cap, that is psi d square by dx square psi 9 psi 9 epsilon psi. So we cancel these epsilon and we are remain with d square psi by dx square equals to 9. So if you have ever been we have gone through the chapter of differential equations, so you will come to know that this is a very general thing, and the solution of this particular equation is psi of x, and that is a e to the power 3x and b e to the power minus 3x. Okay, and yeah, so now we have to see, does this function is finite and is it square integrable, or that is in the very basic word, is this function an acceptable wave function? So we will see if that is true or not. So psi at 0 is a plus b. Okay, we got this one thing because we put 0 at the position of x, and the exponential of 0 is nothing but 1. Now we have psi at the infinity, so a e to the power infinity plus b e to the power minus infinity. So this particular thing goes to 0, but this thing shoots to infinity. So to avoid that, we have to make sure the coefficient a is 0. Okay, and moving ahead, we are remain with psi equals to b e to the power minus 3x. Now this is our wave function. Now we have to find the value of b, so that we can normalize this wave function. So very basic definition is the norm should be 1. So minus infinity to infinity b square e to the power minus 6x dx equal to 1. And one thing which I am doing wrong over here, I just found that in the question, that one particular thing which I am doing wrong is I have forgot to mention that particle is confined to move along the positive x-axis only. So the limit of this integral will be from 0 to infinity. There is no role of minus infinity over here. So we get b square e to the power minus 6x upon minus 6 0 to infinity equal to 1. We have b square e to the power minus infinity minus e to the power 0, so minus 6. This goes to 0 and this goes to 1. That is minus b square equals to minus 6, which implies b equals to 1 by root 6. So our wave function is 1 by root 6 e to the power minus 3x. Okay. Now we have to calculate the probability of finding particle in region 0 to 15. So B, calculate the probability in certain region. So the probability density is psi square, that is probability density. Now probability in dx region is psi square dx. This is our probability. From 0 to 15, our probability will be psi square dx of integral from 0 to 15. Our psi is 1 by root 6 e to the power minus 3x. And the square of that will be 1 by 6 e to the power minus 12x dx. 1 by 6 e to the power minus 12x upon minus 12. 0 to 15, 1 by minus 6 into 12 e to the power minus 12 into 15 minus e to the power 0. Okay, now this value is approximately equals to 0. So we can say that the approximate probability is 1 by 6 into 12. Okay, so that is the question over here. And we can just calculate and substitute. It will be some 0.00 something. And now we have completed the first two questions. Now moving to the third question to see if our given the wave function that we have calculated over here is eigenfunction of operator A. So our operator A is d by dx minus 7. Now applying our wave function to this operator psi, that is 1 by root 6 d by dx minus 7, 1 by root 6 e to our minus 3x. We have 1 by root 6 out common, d by dx e to our minus 3x minus 7 e to our minus 3x by root 6 minus 3 e to the power minus 3x minus 7 e to the power minus 3x minus 10 by root 6 e to the power minus 3x minus 10 into psi. So yes, this is an eigenfunction because we get a constant over here. So a operator operating on some wave function giving a constant into the same wave function, and this constant is the eigenvalue. Alright, now we have the last question of the 50th question, last sub question, that is we have to calculate the commutator of h cap in A. And to calculate some commutator, let us take some test function and we'll see how things work out over here. So h cap A commutator is nothing but HA into AH. Now apply this h cap A cap minus A cap H cap over some test function. Instead of test function, let's take us the psi that we have calculated. Okay, and we know that A cap psi is nothing but minus 10 and h cap psi is nothing but 9 epsilon. So h cap A cap psi minus A cap H cap psi. So we have H cap into A cap psi minus A cap into H cap psi. Substituting values of H cap psi and A cap psi, we get minus 10. Okay, I forgot to put the size over here. Minus 10 H cap psi minus 9 epsilon A cap psi minus 90 psi minus of minus 90 psi, we get 0. So H cap A cap is nothing but 0. So we have calculated the value of H cap and A cap commutator. So we are also done with the last question. I hope you find this question interesting, and this is one of the very kind question to go through in the second chapter. Thank you.